Next, we are introducing several notations that make up ALISA. The background to it is that we have had a variety of notations to deal with our problem space. So first I'm going to talk about what notations have been used by various people and then introduce the notations for ALISA. We have AADL that lets us characterize an architecture specification in the declarative model and then architecture instance by instantiating the ADL model. We have hazard specification and obstacles. Traditionally, those were done by HAZOP type of activities. We can record those with the MV2. In terms of requirements and goals, there have been notations like goal-oriented requirements engineering through chaos. Those notations, since they were not done in the context of an architecture model, included architecture information as part of the requirement specification notation. We have had a draft proposal for a requirements annex for ADL, which focused on requirement specification, but also on verification of these requirements and characterizing those as well. Then we have tools like Resolute and Agree, which also cover a very similar space. They partially let you record the requirements and various forms of verification activities and organizing those in claims and arguments and assurance results. And then we have OMG assurance case modeling notation SACM with version 2 out recently that then focuses on how to organize the claims and the arguments and the assurance results. And finally, we have done work a while back on something called System Verification Manager that also covered a similar space. And so drawing on that experience, we then developed the notations that you find in ALISA without a minimal overlap. So we have AADL and EMV2. We have RegSpec that deals with modeling goals and requirements. We have Verify that lets you specify verification activities and the verification method registry, and then through a variant of it called ALISA specify compositional verification plans. And then when we instantiate the whole thing, we have the assure notation to represent the instance of an assurance case similar to an ADL instance model. So what are those notations doing? In kind of a summary, with RegSpec, we can represent stakeholder goals with traceability to two stakeholders, organize them in document-based format, or organize them around an architecture model if you already have captured one. But more interestingly than when we specify system requirements, those you tend to want to specify in the context of an architecture model because you want to identify elements of the architecture. With the very system requirements, make them concrete enough that they become verifiable, and we have support for characterizing uncertainty and allowing you to specify coverage. With the verify notation, we specify verification plans, which is a set of activities relative to particular requirements of a particular system component, and you specify a claim in which you document which set of verification activities ensure that the claim is satisfied. There's some reasoning logic in this verification activities in terms of the evidence along the lines of assurance cases. We then have verification methods defined in the registries. They become available for use in verification activities, and that registry provides a unified interface to a variety of verification methods implemented in Resolute, in Java, in Python, and various other forms of notations. We not only define verification activities, but also assumptions and preconditions that are made about the verification methods. so that they can be verified as well. The third notation is ALISA. It focuses on the composition of verification plans for various systems and subsystems into assurance cases. And you lay out how deep into the system are you responsible for verifying subsystems, and where is it that you assume they have been pre-verified. It also provides support for filtered views of those assurance cases, so that you can then view them and execute subsets of those activities, focusing on, for example, performance and timing, or focusing on verifying up to a certain development phase, or focusing on only verifying a particular subsystem. Assure, as I mentioned, is the instance notation. That's where we instantiate the assurance case according to the specification, together with the appropriate instance models that need to be verified. And it's in that context where we then execute this multi-valued logic that determines which combinations of verification activities, if they come back as success or failed to execute, namely erroneous, how they then result in the overall verification of the system. So at any point in time, we have a record of how many successes and failures we have on our various subsystems that need to be verified.